Okay, for today, we're talking about reflections. Right now, I asked the students to start with this and then to draw the rest of the graph in. They only know one function that has asymptotes, so they knew it had to be 1 over x. But this one's been moved. So these dots tell you the only two really nice points on this thing. The rest of the points are all decimals and fractions and stuff. How many of you knew that it looked like that? Raise your hand if you did. Okay, good. That's one of the key functions. It's probably the hardest function, and it's on your test for sure. The question is just how will we put it on there? And how many times will we put it on there in different ways? All right, so now, what if I said the rest of this equation actually has to be, well, it's moved over 4 spots. See, that asymptote used to be on the line. It used to be right on the y-axis, which is x equals 0. But it got moved over. It got moved over 4 spots to the right. Should be a -4 down there. Raise your hand if you had a -4 down there. Okay, good. And then the other part is easier. It's +2. Okay, cool. Now, what's the domain and range of that? I'm going to give you a little help. I'm going to say it used to be -infinity to infinity, but you had to say it didn't equal something in the middle, right? It's still like that. It just, in the x direction, you got to figure out what changed. It's not 0 anymore right here. That's what it used to be. And there's more to it too, and I'm not saying. So see if you got this. Now the range, it used to be that it'd be the exact same. But it's not anymore. Because the range is about the y's, and there's one y number that the function can't be. So it'll be the same -infinity to infinity thing, but it will not be exactly the same as a domain. So far, we haven't even reflected this thing. But the hard part really is getting you to understand all the stuff I just told you right there. I know, it's a lot. Today's going to be one of those intense day of teaching things, and then tomorrow is going to be a much easier day. It's going to be pretty much just review of the stuff I did today, and then by the end of tomorrow, you should really be understanding this stuff. Like, I get it, you might not be there yet. Okay, so the domain here, domain is about x's, and this is the one x number that it can't be. That's at 1, 2, 3, 4. And you might be like, isn't that where the asymptote is? Yeah, that's the point. This is the asymptote right here. Which kind of asymptote is that? That looks like a vertical asymptote. And it's not the y-axis, it's x equals, and it's not 0 this time, it's x equals 4. Do you get that you could get the asymptote right there? All right. Little union symbol in there, and then a 4 to infinity. The range is up and down. That's y stuff. So the range, the thing that you can't be is right here, which is 2. So then it's to 2, but it can't be 2. Union 2 to infinity. There you go. You feel like you understand that so far? I know some of you are like, not yet. It's okay. By the end of tomorrow, I'm hoping that you're solid on all this. Okay, so what would be another question we could ask you? We could say, here was the equation y equals 1 over x. If you do this to it, what do you get? And look, this parent function, and you do that to it, it turns into that. Do you get how that works? This is the parent. It's like, that's what it started with. That's how we changed it. And it looks like this now. Okay, here's another question I could ask you about this. In this case, I would not ask you for 3 points because some of them are going to be decimals and they'd be kind of gross and we don't want to give you a calculator. So we won't ask you for 3 points, but we'd ask you for 2. And we'd ask you for the asymptotes. So you just literally have to give me 2 points here. And then you have to tell me what's the x equals asymptote and what's the y equals asymptote. Take a second, look at this graph, and tell me the 2 points that are on it, and the x asymptote, and the y asymptote, and I hope you know the difference. The x asymptote, are you going to know if it's the vertical asymptote or the horizontal? All right, I know everybody can read, so you're like, well, it's 3, 1. But would you have been able to tell me it's 3, 1 by just looking at this? All right, I agree, that's way harder. But if you guess and check numbers in here, you would eventually figure out that 3 is going to work nice because it makes the bottom there into a 1, even though it's a negative 1. At least it's a 1, because then if you have a 1 on the top and a 1 in the denominator, then you have 1 divided by 1, which is 1. And since this is 3 minus 4, it would be negative 1 plus 2, which is 1. So for the other point, I want you to, instead of just looking on the graph for it, think, what other number besides 3 could you put in there and it would work really nice? I hope you're realizing it would be 5, right? Because if you put a 5 here, then you get a 1 on the bottom, and 1 divided by 1 is nice, and 1 plus 2 is 3, 5, 3. See what I mean? You don't have to just get them from the graph, because sometimes we don't give you the graph. All right, and then the x asymptote. Well, x asymptotes are like the x equals thing. I have a dumb way to remember it. You remember it how you want to remember it. I call it the zertical asymptote. I hope from me saying zertical that you can figure out that it must be the vertical asymptote. The x equals 1. See how I put the x with vertical? I'm trying to connect x and vertical for you. The x equals 1, that's the vertical asymptote. All right, so the vertical one is the one that goes up and down. That's this one. Oh, there it is, x equals 4. And you could have got it from right there. That makes that the horizontal asymptote, which I call the horizontal. You can remember how you want to remember it. However you want to remember it, but the y asymptote is the horizontal asymptote. When we give you a spot, here's where you put the horizontal asymptote. It's really common for a kid to put the wrong thing there. You get what I mean? If we just say horizontal asymptote goes here, and you're like, oh, is that the x equals or the y equals 1? So, horizontal and zertical. And in this case, the y equals 1, that's the one that's like the x-axis. And it's y equals 2. And it's that number right there. Okay, that was a lot of info. Understanding all of that is the hard part. But here's the easy part. The new thing for today is officially, I mentioned it already, I even showed you a couple, the reflections. Okay, so I'm gonna go get a nice clean one. Everybody please do the same. Just draw another. And this time let's make it the normal one, where it goes through over 1, up 1, and over this way and down 1. -1, -1. That's the normal one. Oops, it's got to get closer and closer to the asymptote. There we go. And the asymptotes are here and there. Okay, cool. Now, if that's y equals 1 over x, do you get, if I put a negative inside here, down in with the x, or if I went and put it on the outside of it, like here, let me even put a parentheses around it. Let's say that I put a parenthesis. You don't have to, but if I did, whether I put the negative here or here, it's going to be the same exact thing. It's like if I had the number 1/3 and I said, oh, if I put the negative down there, is that totally different than putting the negative on the outside? No, it's the same exact thing. So there are some functions where whether you put the negative inside or outside, the vertical reflect or the horizontal reflect come out exactly the same. And this is one of those functions. Because see, if I vertically reflect this, that means I got to take this and put it down here. And I take this and put it up there. Gonna make my key dot. That red one is the reflection, and it wouldn't have mattered if I did a left-right flip or a vertical flip. The red one would be your answer either way. Because if you put the negative in here or you put the negative out there, in the real world we know that you just made it negative, and it doesn't matter whether it was down there or up here. Okay? There are functions where it does matter. The vertical reflection looks completely different than the horizontal reflection. But this one, they look identical. Okay. This is one where the reflections look completely different. Please tell me you feel like you've seen that before. Either that or you've got a terrible memory. But do you know its name? Say it if you know it. What function's that? I just flipped it, but here, I'll unflip it. Just that. What's the name for that? Square root of x. The square root function. Square root of x. Both of those are good answers. Okay. Now, do you get, it would be quite different to flip it this way as compared to taking the blue function and flipping it that way. One of them was a horizontal reflection, and the other one's vertical. So which one's which? I'd like you to put all three of these on a graph, and I want you to call this one, let's keep it the same color. Y equals the square root of x, that's the blue one. What's the white one? And what's the green one? This is the one function that I think shows the difference between a horizontal reflect and a vertical reflect the best. Excuse me. You can just write square root of x on all three of them, but then you got to put a negative in the right spot. Okay. If you draw a line like that and you go, oh, that's like this way, you should be able to know that that's horizontal. If you don't have your horizontal and your vertical figured out, that's going to be really hard this unit. That's horizontal. Okay. And if it's horizontal reflect, it's got to be on the inside. How do I know that? Because it's high. Horizontal if it's on the inside. And if it's the vertical kind, it's going to be a vo, vertical on the outside. So high vo. If you just remember that, high vo. Horizontal inside, vertical outside. So this one right here, that was a vertical flip. Because see, it went up and down. That's vertical, kind of like a vertical leap. And vo, vertical on the outside. There we go. There's your negative on the outside. Okay. Again, misconception time. People see this and they go, it's a trick question. You can't do it because there's no negatives allowed on the inside. Nope. It just means the only kind of X's you can put in are what? Negatives. See, if you have that graph, you can totally do that graph. We just graphed it a second ago. It was one of these two. It was that green one right there. That's that graph. It's not like it can't exist. Of course it exists. I just showed it to you. But I get why people think that, and I like that they're realizing you can't do square roots of negatives, but it just is telling you you have to use negative numbers. So would you please find 3 points that would be on the square root graph? That one, the one with the negative on the inside. I'm going to pause for a second. We find those 3 points, and then I'd like you to graph them. Graph those 3 points. And then I'd like you to tell the domain and range. We just keep on hitting domain and range over and over again because I think it's the hardest one for kids to get. Once you got the graph, do the domain and range. I personally wouldn't try domain and range without the graph. I would always sketch it quick. Okay, just so you know, I just double checked and we're on track for a test about a week from now. So it's not the end of the week, it's a week from now. And you might be thinking, I feel like I'm good at this. Well, there's obviously a lot more between now and then. So far we've done reflections. After that, we put numbers in front like this. Let's say I put a 7 in the front, and you're gonna have to learn how that stretches it. And a stretch is not the same as a reflect. So I'll have to teach you that a different day. So, all right, and we're also kind of slowing down a little bit because we've come to a religious holiday, and so we're going to like take an extra day in here to make sure you're good. I know that these are kind of hard, so. All right, so if I were to pick points, I would have picked 0 because even though it's not a negative number, it's gonna work. Square root of 0 is 0. Now, do you have to use that point? No, but then you might mess up your domain and range if you don't know 0 can go in it. Also, -1 works because when you put a -1 right there, you have -1. Square root of 1 is 1. And the next one is, I'd say probably 4, because the square root of 4 works nice, except it's got to be negative, and then that will be 2. So here's 3 points, -1, 1, -4, 2. There we go. And that's kind of where we knew this thing was supposed to end up from the previous slide. And it's a negative, which is in the inside, which is a left-right, also known as horizontal reflect. Now the domain of this thing is from left to right, which is negative infinity. If you said 0, I understand, but you're wrong. The furthest left it goes is negative infinity. The furthest to the right it goes is 0. And it does touch 0, so it's a bracket. Okay, then the range is how low it goes. I really think asking how low it goes helps. Because then when you're looking at this number, you're like, oh yeah, that is the lowest it goes, it's 0. And what's the highest it goes? It will keep going up, right? That's positive infinity. And I get some people think that's negative infinity, Mr. Server. No, the range goes this way. So what's the lowest it goes on that green arrow? 0. What's the highest it goes? Infinity. All right. You don't have to be perfect yet. Test isn't until next week. Okay. So, any questions? Are you feeling like you're getting it? Awesome. So from here, there's a bunch of homework questions that are like this. There's one more kind I want to address. And I said homework. It's practice problems in class. Like I said, being a religious holiday, we are not going to assign you homework. It's just some problems you should do in class to practice this because to get good at it. And here's a different looking question, but it's just really the same kind of question. Square root of negative x plus 8. What are the transformations to the parent function? Try to answer that question. I didn't say to graph it. I didn't ask for the domain. I didn't ask for the range. What are the transformations that have been performed to the parent function? Once you see what I mean, you'll get it. It's there's two kinds of reflect. It's a reflect for sure. And it's on the inside, so it's a horizontal reflect, and then it's up 8. Those are called transformations. This one, you want to get even more confusing, that one's called a translation, and that's called a reflection. But together you can call them transformations because they transformed the function. Okay. What if I said this? This time, I told you what to do with it, I just didn't tell you what the function was. So you can still tell me the transformations. You just don't know if it's a square root, or an absolute value, or just a squiggly little picture. So what are the transformations? All right, there's a vertical reflect. Now, I'm going to, on purpose, do this the same way that they do it in pre-calc, which is they usually start with the stuff on the outside, and then they do all the stuff on the outside first, and then they tell you the stuff on the inside, because there is an actual order. You know order matters in math, right? PEMDAS, remember that? Well, the order that you should write these down in, right now on your key, it won't even care. But I know where you're going, and I know that eventually you're gonna have to know what order to do them in, and you don't go from left to right. You know that about regular math problems too, correct? It's a PEMDAS, that's the order you do it in, and sometimes that's left to right, but most of the time, there's a little twist in there, especially in an honors class. Okay, so you've got to do both outside things first. So that's the second thing we would do is the up 5. And the last thing that they do in pre-calc is they do the inside. The inside was a right 3. So, do it outside in. I personally like inside out, but more teachers, I don't want to confuse you, and so more teachers do it the other way, more teachers do outside in. And the key is you cannot just go left to right. You'll only occasionally get lucky, and that could be the right order. That would be, for instance, let's say there was nothing inside. Well, then it is going to be kind of from left to right. But you'd have to get lucky to have it work out that way. All right, so what's the order? Outside stuff first, then do the thing on the inside last. Okay, cool. And this is a list of transformations. What if that was the question and they wanted you to graph where this was the starting graph? It's like a little kind of not symmetrical little pointy mountain. And they said, do this to it. Well, this is f of x. That's like the parent function. They gave you this little pointy mountain thing, and they want you to do this to it. Well, that is, in my opinion, the hardest question on the test. Not saying that question is on the test. I'm saying there's something like that we test you on. Would you know how to vertically reflect this thing first? I could take the little pointy mountain and vertically reflect it. Could you? I don't feel like it's that hard. And then could I move the whole pointy mountain up 5? Yeah, it won't be a mountain anymore because it'll be flipped over. It'll be more like a V shape. But then I could move it up 5. That's easy. And then can I move the whole thing to the right 3? Yeah, that's not that bad. All right, so I want you to actually do it. Take a second. Craft a little pointy mountain. And move it in those ways. All right, the vertical reflect part. I think you know it's kind of like this, but you gotta be careful. You can't just make it a symmetrical mountain down there because it isn't. So since it's vertical, you just go literally straight exactly across. And it used to be 3 blocks high, so it needs to be 3 blocks low, right? And there. I think I better draw this a little more carefully. There we go. There, that has been vertically reflected. And then I move the whole thing up 5. I'm taking this spot at 0, 0, and I'm going up 1, 2, 3, 4, 5. And then it moves 2 to the right and down 3. And that's that point moved up 5. Okay, maybe I should do them in green. There and there. And then this last point has to be moved up 5. And now it's a V shape again, but moved up 5. And the last thing is right 3. Make the last one white again. There's my final answer. It's a flipped over little pointy mountain that's been moved up and to the right. Okay. Now, I have covered a lot, and I get that there might be some things in here that you don't get yet, including domain. I'd like you to do the domain on this one, and then we're just going to start some practice problems. And all I'm going to ask is that for the rest of the hour, you work on some practice problems. See that thing right there? What's the domain and the range of it? What I really asked is how far to the left does it go and how far to the right does it go? And how far down or how low does it go to how high does it go? We're talking about this. I'll make it a squiggly white and blue one. That one. What's the domain of the squiggly white and blue one? And remember, it touches. On the left and the right, it touches those spots. There's no asymptotes. And the low to the high, that also touches those spots. All right, that one I'd like you to compare with the kid next to you. It'll look something like this, bracket, with a couple numbers in there. So here's what domain's like. It's like this green line here. It's like how far does it go to the left and how far does it go to the right? And the furthest to the left that it goes is right there, which is 3. And the furthest to the right that it goes is 4, 5, 6. 3 to 6. Raise your hand if you had 3 to 6. Nice. And then the range is how low does it go, which is down here. And the lowest it goes is 2. It's up 2 when it's at its lowest. 2, 3, 4, 5. Is it 5? Did you guys get 5? Okay, 2 comma 5. And the range is how high it goes. And I'm just going to double check that. 1, 2, 3, 4, 5. Yeah, 5 is the highest it goes. So 2 comma 5. I need honesty here. I don't know if I hear some people saying they're not getting it and other people are saying they're getting it. Who had that exact thing? Raise your hand if you had that exact thing. All right, there's only like 3 or 4 people. All right, so let's do one more like that. Now that you understand what I did, maybe, I hope, we'll give you one more like that. This little lightning bolt has a domain and a range. It's not an arrow on the ends. It's dots. I'll make it really extra clear. It touches 0, 0 right there. And it touches that spot, which I'll help you count. I know from a distance it might be hard. That's 5 comma 3 right there. All right. Please compare this one to the kid next to you. All right, good. Shaharsh, what'd you get? How far to the left does this thing go? 0. That's the furthest it goes that way. Okay. How far to the right does it go? 5. Notice domains are about x values, so I picked the 5. Cool. And then the range. Shaharsh, how low does it go?
0.
The lowest it goes is 0. To the highest it goes?
3.
And does it actually touch that?
Yeah.
Yes, it does. Brackets. Brackets all around. Who had 0, 5, 0, 3? Okay, good. We're almost all there now. Okay, so you have some practice problems to do. Today, I'm going to suggest that you do the 5 problems on the worksheet. I want you to do 2 that you find like comforting and like no problem. And I want you to find 3 that scare you. Because they're all going to eventually be on the test. Okay, so this is make your own assignment day. Instead of telling you to do all of them, I think you don't have time for that. Because realistically, I really want you to be able to finish this out. I think you should do 5 questions off of the worksheet that's there. And again, you're never even going to turn it in. This is an on your honor kind of thing. I think you can get 5 done before we leave today. Do 2 easy ones and 3 scary ones. Okay? All right. That's all I got for you for today.